The next way of doing this is called elimination. And in doing elimination, what we're doing is we're eliminating one of the variables. Let's use those two same equations just because we have been using them and we know the answers, so we're sure of what we're going to get. And what I want to show you here is just different ways of solving the same thing. So in this case, what you want to do in elimination, you want to put it in this form. Put in the form ax plus by is equal to c. So that's the form we want. So let's change this one, okay? And we're going to call this. So I'm going to change this one and so that it's in the same form as this. If I'm going to put it in the same form, let me redo it. So I'm going to call it equation 3, and I'm going to put x plus y is equal to 2. And I believe I didn't do anything different, just brought the x over. And so now I'm going to rewrite my number 1, 2x plus y is equal to 6. Now, the one thing you need to understand before we can do any of this is I'm going to show you a little side piece of knowledge here. If I say 3 plus 2, we know that's equal to 5, right? And I know that 5 plus 2 is equal to 7. Would you agree with that? Absolutely. And so I look at these and I say, you know what? I want to eliminate the 2's. And I'm going to put them on top of each other and subtract. And let's see what happens. 3 minus 5 is negative 2. 2 minus 2 is 0. 5 minus 7 is negative 2. This works. And this is mathematically correct. And you can all agree with this. So I'm going to do the same thing here. And what I'm going to do is I'm going to eliminate one of my variables. And as you can see, the one that can be easily eliminated is this y. I can do that by either adding or subtracting depending on the sign. If both are pluses, then I will subtract. If one of them is a negative, then I can add. So I'm going to say 3 minus 1, and that's x minus 2x. That leaves me with negative x. Y minus y is 0. 2 minus 6 is negative 6. And so x, it is not negative 6. 2 minus 6 is negative 4. And then if we're going to divide by negative 1 on both sides, x is equal to 4. And we know that if I plug this in, I'll get y is equal to negative 2. And this is called elimination, okay? And again, what you're trying to do is eliminate one of the variables, if it's possible. So you can rearrange your equation into ax plus by equals c. And then once you've done that, you can either add or subtract. If the signs are the same, just subtract. If the signs are different, then you can add the two. And this is one way of using elimination. I'm going to show you another way. Now again, I will rewrite this equation the way we had it, because for the elimination, you also have to write it like this. So number 2, we had, I believe, x plus y is equal to 2. Now, I know that it's obvious that the easiest way is to do this, but what I can do, let's say I wanted to eliminate the x's. But in order to do that, I would have to have the same numerical coefficient as here. For now, this has a 1, this has a 2. In order to have the same numerical coefficient, I would need to multiply this by 2. But you can never do one thing to one term in an equation. You must do it to all. So I'm going to say 2 times 2. I'm going to take this, I'm going to write 2x plus 2y is equal to 4. And now this is my equation number 3. I'll bring back equation number 2, and I have 2x plus y is equal to 6. And what I can do now is, as you can see, I can eliminate these ones by subtracting 3 minus 1. This minus this is 0. 2y minus y is y. 4 minus 6, negative 2. And we know that this is the correct answer. Okay? And that's another way of doing this. is by multiplying the entire equation so that the numerical coefficient of the variable that you desire to eliminate is the same. Okay? Now, sometimes the variables on both, the numerical coefficient on both variables are different. And so this is what we're going to do next. Okay, so we're going to continue, and this time we're going to have a new set of equations, and here they are. And let's look at this and see that for this one here, the problem is that both numerical coefficients for the x's don't match up, for the y's don't match up. And I can't even multiply, if I multiply this, I also have to multiply a number for this one, because 3 is not going to be a 2 and 2 is not going to be a 3, and vice versa, 5 and 2. That's not going to work. So what you want to do is you want to find a common denominator, the lowest common denominator, and choose which one you want to eliminate. Let's eliminate y. If I want to eliminate y, what number can I use to eliminate both? What number do I need to multiply the top, this equation by, and what number do I need to multiply this equation by in order to be able to eliminate the y's? If I multiply this by 3, and this one by 2, I will get 6y here and 6y here, and therefore I can eliminate them. So let's do that. We're going to call this equation 3 now. So times 3 gives me 15x plus 6y is equal to 27. And then this one here we're going to call 4, and that's 4x plus 6y is equal to negative 6. And now I'm going to decide, do I subtract or do I add? Because they have the same sign, we're going to subtract, So 3 minus 4. 15 minus 4x gives you 11x. We know that these are eliminated. 27 minus 6 will give you 33. If I divide both by 11, x is equal to 3. And there we have it. And then I can choose to plug this into either one of the equations, this one or this one, to find the y. So let's plug it into number 2. So if we have 2x plus 3y is equal to negative 3, and then I'm going to plug in the x here, 2, and this is times 3 plus 3y is equal to negative 3. I've got 6 plus 3y is equal to negative 3. Bring that over. 3y is equal to negative 9. Divide both by 3. Y is equal to negative 3. And so what I've done here is I looked at both of these equations and realized that the numerical coefficients are not the same for either of them. So I'm going to have to multiply either this equation by 3 and this one by 2 to eliminate these ones, or I could have multiplied this equation by 2 and this equation by 5 and eliminated these two. In the end, you'll get the same result. And this is what you can do with elimination. For every equation, you can multiply it by any number you like, as long as you are doing it to every single term in the equation. And that keeps it equal.